To understand the most powerful machine ever built, we must first clear up the confusion of its name. Nuclear bomb is an umbrella term. It is a family with two distinct siblings. The atomic bomb, fission. This works by splitting heavy atoms like uranium or plutonium-239. It was the power that destroyed Hiroshima. The hydrogen bomb, fusion, also called a thermonuclear bomb. This works by fusing light atoms together. The hydrogen bomb is a nuclear bomb, but it is a higher-tier weapon. It is the leap from limited power to theoretically unlimited power.
In 1951, the Hungarian-born Edward Teller and the Polish mathematician Stanislaw Ulam discovered the secret blueprint. They realized a hydrogen bomb isn't just one explosion. It's a relay race between two separate rooms inside a heavy metal radiation case. The primary, the top, a compact plutonium-239 fission bomb. It is the match. The secondary, the bottom, a cylinder containing hydrogen fuel, lithium deuteride. The transfer, the void, the space between them, filled with a special polystyrene foam.
The explosion begins in the primary. As the plutonium atoms are split, they become violently excited. The temperature skyrockets to 100 million degrees Celsius, hotter than the center of the sun. At this heat, the plutonium doesn't just explode with fire, it glows with a blinding flood of X-rays. These X-rays are the key. Because they move at the speed of light, they reach the bottom of the bomb in a few nanoseconds. Here is the great engineering dilemma. The bomb is in a race against its own destruction. When the plutonium fires, it creates a physical shockwave of debris moving at supersonic speeds. If that slow shockwave hits the hydrogen fuel first, it will shred the bomb before it can fuse. But the X-rays are faster. They reflect off the gold-lined walls of the casing like a mirror, channeling the energy downward. They hit the polystyrene foam, turning it instantly into a high-energy thermal plasma. This plasma widens, not just in size, but in particle density and number. This widening creates a violent blow-off called ablation. The plasma blasts outward, creating an equal and opposite force, a 1,000,000-ton hammer that shrinks the secondary stage, squeezing the hydrogen fuel from all sides. Inside the shrinking fuel, the atoms desperately try to repel each other, but the pressure is too great. This shrinkage forces the atoms so close that the strong nuclear force, the glue of the universe, snaps them together. They fuse. In that tiny delay, measured in billionths of a second, the light wins the race. The hydrogen fuses before the physical blast can destroy the machine. The result is not just a bomb. It is the birth of a star on Earth. The Americans were the first to test this sun in 1952 with Ivy Mike. It was a massive 10.4 megaton building, too heavy to fly. The Soviets followed in 1953 with RDS-6S, a layer cake design that was smaller and droppable from a plane, though less powerful. But by 1955, the Soviet genius Andrei Sakharov discovered the same third idea, the X-ray mirror secret, leading to the RDS-37 test. Both sides now held the keys to the world's destruction.
The race reached its terrifying peak in 1961. After a massive spree of 57 tests in a single year, the Soviets detonated the Tsar Bomba. It was a 3-stage monster, 50 megatons in scale. It was 3,333 times more powerful than the 15-kiloton bomb dropped on Hiroshima. The flash was seen for hundreds of miles. The shockwave circled the globe 3 times. It was the most powerful hydrogen event in history. So powerful that its creator, Andrei Sakharov, turned away from weapons and spent the rest of his life pleading for peace. While Hiroshima proved we could split the atom, the hydrogen bomb proved we could harness the stars. It is a machine where light is a hammer
and the only limit to the explosion is the size of the container. We now live in a world where we have mastered the nanosecond, and in doing so, we have mastered the fire of the universe itself.